And thank you for the intro, Tony. Like Tony mentioned, I am the organizer of Scala Up North, which is the first and only Scala conference in Canada, based in Ottawa right now. And I've been doing the Scala stack, so Scala, Akka, and Play, for about 6 years now in total. More recently getting into Logom as well, the new framework from Lightbend. And I've also been doing training for quite a while, so I'm very comfortable and familiar with the technologies. So today we're going to focus on circuit breakers, and I am going to stop my webcam here just so we can focus on the slides and content, and so that you forget about the fact that I didn't go through makeup today. So I'm going to stop that, and hopefully everyone can see my slideshow now. Just going to make sure that I am sharing indeed, and I should be. I am. There we go. So, like I said, we're going to talk about Akka's circuit breakers. So we'll start by talking about timeouts, and we'll work with a simple example, a simple app, and we'll look at where the use case is for them, what circuit breakers can offer, and how do we think about them, how do we, when do we use them, how do we implement them. And we'll have a small running app that we'll use as a quick playground. Okay, so to dive into the content. So this is the type of scenarios that we're concerned about. So imagine this be a simple application where we have some kind of client on the left-hand side. We're representing them as users. They could be literally a human being, a person in front of a browser trying to access a website, but it could be any other type of client. It could be a JavaScript app trying to do HF requests, other services trying to come in. So on the left-hand side, we don't have control over what they're doing. On the very middle left, there's our profile service, right? So that is the main piece that we have control over. This is the application or the component of our application we'll be writing. And then we have a dependency to the right-hand side to something external. Could be a web service, could be another service in our own architecture, could be a database, all kinds of things, right? So this is the type of scenario we want to play with, and we'll look at how what the problem is first. Okay. So the type of problem we're trying to look at is, well, what happens when our web service starts failing, right? And this could be because the whole service is down, because there's a network outage, or because it's responding very, very slow, right? Many times I won't be able to know which one of those three. All I know is that from my profile service perspective, I see that requests being sent to the web service are taking very long to come back. So the responses are taking very, very long. Okay. Now, because I want to be lenient with my web service, and again, we might be going over networking, I might have a rather long timeout here. So I might want to give that web service, let's say, just for the sake of discussion, 10 to 20 seconds, right? Let's say 10 seconds to respond. Now that is a very long timeout, especially if we're talking about human beings, us our clients. We know that people are not very patient when it comes to using websites and using web apps. So they say that the average user will wait for any content to be served something like 8 seconds, sometimes even less. So the fact that we're being very lenient with that web service is then hurting the response time to our clients directly. Okay, so now that long timeout between my service and my web service is being propagated back into the clients of my profile service. That's not very good, because what will happen is we'll typically see two types of responses to that, or two types of behaviors. One will be that people just leave, right? So a client will just give up and leave, and they won't get any kind of error message because we still haven't served any kind of response. And the second behavior we'll see, which might make things even worse, is that people start clicking reload, or services are trying to do retries too quickly. Okay. So both of those are really bad. We don't want any of those. We want to try to avoid that. So we can easily implement our own logic to try and detect this type of scenarios, but we'll see how circuit breakers can make it a little easier for us. Okay. So just reviewing what the type of scenarios we want to look at, we have calls that are timing out. So a call to a web service is timing out because we're not getting a response quickly enough. Okay. This could also be that these calls are failing with some kind of exception. So both of those are the type of scenarios we can work with. Now, if we had a one-time failure only, that's not a big deal, but we're more concerned about when there is a pattern of consistent failures. So what happens if, I keep sending requests to the web service and they're not coming back at all, okay? If it's a consistent issue, if I see a pattern of failure, then I'm going to want to have a different solution for this. I might need to keep track of how many failures, how often, et cetera, et cetera. And this is exactly the type of issues where circuit breakers will shine. What we want then is the ability to detect this pattern of consistent failures and to respond to our users very quickly. Okay? So what we're looking for something like this. What we want then is here in between the profile service and our external web service, we're added one component that's my circuit breaker. Okay, and we'll look at some code to understand how that works. What we want is a long timeout to not propagate back, but we want our circuit breaker to help us determine when we've entered this pattern of consistent failures, so that when we realize that's what's happening, we can quickly respond to our users without waiting for the web service, without even attempting. We can quickly go back and say, sorry, we're having an issue, internal error, however it is that you want to present that, but some kind of message or some kind of status code that indicates, can you please try again later, because we're having some issues here, okay? So let's focus on what that circuit breaker is and how we can use it. So a circuit breaker is a relatively small object that can be in one of these three states. And here, of course, the metaphor is for current flowing, right? So a circuit breaker can be on a closed or an open state. So when our circuit breaker is closed, it means life is good, everything is cool, and all calls going through the breaker are actually making it through. Okay? And we're getting responses back in a reasonable amount of time that are not failures or exceptions. So this is, of course, where we want to be, that closed state. Now, what will happen is some of those calls might start failing. Some of those calls might time out. So we have the two possibilities. And the circuit breaker is going to keep a count of how many failures, consecutive failures, there are. And when we pass a threshold, then we're going to trip that breaker and move into that open state. Now, open is red, red is for bad. We don't want to be in the open state, but we got here because we detected too many failures successively. When a circuit breaker is in the open state, it's not going to let anything through. All calls or anything that we try to go through that breaker is going to fail fast. That's what we want. We want that fast failure because we've realized we're in a pattern of consistent fails from whatever it is that is on the other end of the circuit breaker. Now, once we're in the open state, there's going to be a cooldown period here, configurable amount of time, where all calls are failing fast. And after that time passes, we're going to go into this sort of trial state, if you will, called half open. When we get to half open, we're only going to let one call through. That's our test. We're like, okay, let's give this just one try, one attempt to see what happens. If that one attempt succeeds, we go back to close and everything is good, we're back to normal. But if that one call fails, we go back to open. So we could potentially be bouncing back between half open and open if the thing on the other end of the circuit breaker is never responding in a timely manner. Now, for a couple additional details in here, when we're in the closed state, everything is good, calls are going through. The failure counter is something, of course, the circuit breaker takes care of, so we don't need to worry about it at all. We only configure when we create the circuit breaker how many failures can we tolerate. Now, we said we're counting the consistent failure pattern. So if we see a few failures without still triggering the circuit breaker and we start seeing successes, that success resets the counter. But when if we reach that threshold, then we're going to move into the open state. Now when open, we get a fail fast, and that reset timeout, also configurable, is going to move us into the half open. Half open gives us just one call allowed through. If there are any other calls at this point, they're just going to fail fast as well. Okay, so while we're still doing that one test call in the half open state, anything else is just going to fail fast. But if we succeed, we move back to closed, life is good, we're back to green. If it fails, we go back to open on the red. Okay, so in addition to that, because we're transitioning between these three different states, a circuit breaker has a very simple way to register callbacks. So let me know when you're moving into the open state or the closed or the half open state. So I can use those listeners or those methods to register a callback so that I'm notified when those transitions are happening. I might want to log some things. I might want to notify an admin or some other type of system that this is happening. Okay. So here's a simple example of creating a circuit breaker. So here I'm inside an actor, and I'm creating a circuit breaker, and here we see the configuration that we need to provide. So the first thing we see is that a circuit breaker requires a scheduler. And this is important because the circuit breaker needs to do or run some tasks that have to do with time. When we go to the open state, we're going to need to wait for that cooldown period. So that behavior is going to need a scheduler. So here I'm just providing the scheduler of the same actor system where this actor is running. Now the max failures indicates how many, what's that threshold, that max amount of failures that that can tolerate in succession. So if we see 5 failing calls in a row, then we'll trip that circuit breaker. The call timeout is how long I'm going to wait for the response to come back. Okay, so if a call through the circuit breaker takes more than 10 seconds here, I'm going to consider that a failure. And the reset timeout is just that cooldown period. So how long am I going to stay in the open state until I try my half open or I do my test to see if I can go back to close. And like I mentioned, we have those 3 methods to register callbacks so that I know when a transitioning is happening. So here I'm only registering a callback for when I'm moving into the open state. So this is how we create one. So now that we have it, how do we use it? There's 2 variations of how to use the circuit breaker. So once we have an object of type circuit breaker, we can call this method in here with circuit breaker and pass in an expression that returns a future. So this is for asynchronous calls. So when this returns a future in here the async WS call, that's a method I have in here, returns a future of a string. And then I'm going to take that future in here. I'm doing something very simple. Once that's done, I'm going to pipe it to my sender. So this actor receives a request. It's going to try to talk to the web service, but it's now doing so through the circuit breaker. If that call fails with an exception, or if it times out, that's going to be considered a failure from the circuit breaker point of view. Now, what happens if you have an expression that returns not a feature but something else? So if you have a blocking call, a synchronous call, like the one I have here, WS call just returns a string, does not use feature at all. Then we have a slightly different method called with sync circuit breaker. So because we're not using futures, we can just take the value that is returned from that method and use that as a message to send back to the sender. So this is how you do a call through the circuit breaker using these 2 methods. And now all the configuration we've set, the max failures and the timeouts and all that are going to be baked into that object. So let's take a look at a slightly more elaborate example, and let's see it running, see if we can detect where the improvements are. So what I have here is a small system that represents exactly what we're talking about. So let's start with the application, and we have a couple other classes to review. So on the bottom, on the very top, we have our application where we simply create an actor system, and now we create a service. So that's the thing in the middle of that diagram we were looking at, and this is the key to handling the timeouts. Now we're also creating 10 users right now. Okay, so those are the clients that are sending requests into my service. The ones that are not particularly patient, they'll actually give up after some time. And we'll look at the user class in a moment. Now, just for a demo purpose here, and to make this a little bit more realistic, I'm actually creating those users as user actors, and I'm also straggling them. So they're not all created at once. That's why the creation of my user actors is inside a scheduler in here. Because what I want is users to arrive, not all at the same time, but roughly every second. And we'll see that when we run it. This just provides a more interesting and more realistic sort of behavior. Okay, so that's the top level application. So let's take a quick look at the user actor. So the user actor is the one that starts the request. So as soon as we create one of those, I'm going to start sending my first request. And here I'm using the ask pattern. So the user actor sends a request and has a timeout that's not particularly long. So here we've set it to 3 seconds. So the idea here is that a user after 3 seconds gives up. Okay, and that's reflected in here. If we look at the receive method, if you get a regular response, this is the expected content that you want from the service, then this actor is happy. I got a quick response, I'm a happy actor. And then I send the next one. And I send the next one after a small delay, right? 1 second by default. So if everything's good, if the service never fails, what I should see is this user sending a request, getting one back within a timely manner, and then waiting for a second and sending another one. And we'll see that on and on. Now, the next type of message we can see in here is a failure with an ask timeout exception, and that's because we're using the ask pattern in here to communicate to our service. So this timeout is bad. This is the user got bored, the user got angry, they don't want to be here anymore, so they just say, okay, I'm out of here. And if they do that, we stop the actor. Okay, so you'll see actors dropping if they get bored of waiting. And let's stick to that for now. Let's not look at this just yet. Okay. Now we're going to test first using a service without circuit breakers. So this is as simple as it gets. This service is basically just a proxy. It gets requests from the users, and then it calls a web service. And whatever results of that, we're going to send back to the sender. So let's look at this method over here, which I've moved to a common trait. That call web service has 2 possibilities. There's a 90% chance that things are good, and I'm just going to respond with an object over here. Now, I know what you're thinking. You're thinking you're doing something awful, Alex. You're using thread to sleep. I know. Thread to sleep should never be used. I'm doing it here for demo purposes. So this is simulating a web service that takes a little bit of time to come back. Here we're saying 100 milliseconds. That's fine. Now, there's a 10% chance that this one call is actually bringing down the service. And that bringing down the service simply means that we're doing a much longer sleeping here, to just over 3 seconds. Okay, and of course I made it on purpose just over 3 seconds so that we can see the users getting out or dropping out from the system. Now, note that in both cases we will get a response back. Okay. So in the service without circuit breaker, we will always send back a response, but it might be within 100 milliseconds roughly, or just over 3 seconds. Okay. So now let's take a look at that running. So if I go here, I have that application I've opened Activator already, and then I'm just going to type run in here. So if you follow what the log messages are, you will not be surprised. Here we're very unlucky because the service got overloaded on the very first attempt. That's fine. So we see, oh, hold on a second. Let me stop this in here. Just making sure that I have the right, oh, I'm using the incorrect service. I'm showing you the right solution. Not yet. Okay, let's try that again. I'm going to recompile that one source file. So what I'm looking for in here is, well, some actors are getting quick responses. That's all nice and good. At some points, the service is going to be overloaded. It won't be able to respond quickly. And here we go. We see some users are dropping out. Right? So they get bored. Out of here, if you remember, we're doing context stop. So that user is stopping itself. So after a little while, not very long, all users have dropped and they've been removed from the system. Okay. That's exactly what we're trying to avoid. So to avoid that, or to have a better handling of this situation, we're going to use a slightly different service that has a circuit breaker, of course. So if we go in here, we see service being represented as an actor, where we're creating a breaker very much in the way that we showed in the slides. We're using the same scheduler from the current actor system. Now we're being very intolerant here, just so that we can see results fairly quickly. We can only tolerate one failure. So just the one failure in that web service is going to trigger or trip this circuit breaker. Now we're also saying, and this is important, we're saying that the timeout is 2 seconds, which means if the web service takes longer than that, we're gonna handle that as a timeout. And if you recall, that will be considered as a failure from the circuit breaker point of view. That timeout is very important. So here we want to pick an amount of time that is reasonable for the clients of this circuit breaker. And then our reset timeout is the cooldown period we have. We've set it to 10 seconds. If this was a real application where we're actually talking to an outside web service, we probably want something that's a bit longer than that. And just so that I can see things in the logs, I have callbacks on all 3 transitions, to open, close, and half open. And now here's where I'm using my circuit breaker. I'm saying, well, I'm going to call that web service, wrap it in a future, and then use my circuit breaker for that. If you remember, this call is the one we want to use if you're doing asynchronous calls. And in the majority of cases, we will. So this is the most common usage for this kind of module. And whatever results from calling this, which is going to be successful if the call return a value in a reasonable amount of time, then we're just sending back to the center. Okay, so this will go back to the user. So we make sure I've enabled the right service, I have, and then let's come back in here and run it again. So now what we see is, again, some actors are happy, they get a response quickly. When we get a service overload, then the users are saying something different. They're saying, well, something must be wrong with the server. I'm going to try again in a few seconds. So how come we're seeing that message instead of the I'm bored, I'm out of here? Okay. And we're seeing that because what's coming back from the service is a response within a couple seconds, because that was a timeout we chose. And the message that we're sending back is this failure. So this is what we're using here very simply to represent, hey, something's wrong. Will you try again in a few seconds? Okay, so this could be a nice error page, a nice error message, or a status code that talks to whoever's calling this API saying, hey, there's something wrong. But the most important thing is that this failure is coming back quickly. This response is coming back before this timeout expires. So well under 3 seconds. And now we're hoping that these users or these clients are more lenient and more tolerant, and that they will wait for a little longer. So the way we're representing that is the next request is actually going to have a time or initial delay of actually 5 seconds. So the user is waiting for a little bit and only then sending another request. So if we go in here, if we did everything correctly, this is still running, so we haven't dropped any users. Every time they get a failure like this, they wait for a little bit and then they try again. Okay. So that is a very simple use case for this, but this is the pattern we want to follow. Combine circuit breakers, typically with futures, even though there is a synchronous or a blocking API as well. But what we want is to configure it properly so that we can detect the pattern of consistent failures. And when we do detect that, we have a special behavior that says, well, you know, here's a nice error message, here's a nice exception, will you wait for a little bit? Okay, let's see. So there's a couple, or there's another thing that we want to know about circuit breakers. This pattern, or the pattern we just showed, works very well in combination with futures. But what happens if the thing I'm trying to control in here, if my circuit breaker is sitting between two actors, for example? Let's say we had this architecture already and we're introducing a new circuit breaker in between two actors. If the proxy actor here is responding with a message, that message is going to go directly to the profile service actor. It's not going to go through the breaker at all. So we send a message through the circuit breaker. Because this is now responding directly here, then the circuit breaker doesn't know that this response came back. Okay? So you don't get this for free. Circuit breakers don't really support this type of flow immediately or out of the box. Now, so then what do you do? Can you use circuit breakers at all? The answer is yes. The answer is you can use what's called the low-level API, also called the power user API, apparently. And you would use it like this instead of calling the with circuit breaker methods. Then you can call methods on the circuit breaker to check what the state is. Is it closed? Is it open? Is it half open? We have some methods to modify the state of the breaker. Okay. So in this example that we've encoded here, if we have two actors, and what we want is to have the circuit breaker help us with this flow over here, what you would see is something like this. You would see the profile service actor doing the following. When they get a request, this is a user sending a request, I want to go to the web service proxy. I'm going to check the state of the breakers. I'm sort of doing a manual checking here, right? So if we're good to go, then we send the message to the proxy, and we expect that proxy to send a response back. And otherwise, we just take a fast fail or respond with a fast fail message. So we're actually taking that step manually ourselves. And then whatever represents a success for you, you can call this method here succeed, and succeed, if you recall, will reset the failure counter if we are on the close state, or it will move us into the close state from the half open if that's where we are. And we can also call fail, and fail is to manually indicate that we've detected one failure. Okay, so that will increment the failure counter and potentially also move us into the open state if we've reached our threshold. Okay. So this is a lower level API, gives us access, direct access to the state, and both in read and write mode. This is still thread safe, so we can we can use these without any fear, particularly from actors, because we have the single threaded illusion, of course. Now, even though this API is available, I would say if you're going to use it with care. One of the things that you might have noticed is that not all methods actually make sense in all states. So for example, if you're in the open state, any calls that come in should fail fast. So we should never register a succeed or a success when we are in the open state. So now that we've been given the power to call any of these methods, we could potentially call succeed in the open state. It won't have any effect. You're not really going to break the circuit breaker in any way. But it's simply a call that doesn't make sense. So you might think that you're doing something that you're not really doing. So that's the first thing we want to be careful about. You also don't get an automatic one request on half open. So remember, when we're in half open, we're only going to do one test. Let one call through. And if that succeeds, we go to close. If that fails, we go to open. You don't get any of that. So you would have to implement that yourself. Now, it is possible that you need to use this, so use it carefully. And make sure that you're handling all the states in all the, or that you're handling the transitions correctly in all the states. And as always, you can use your callbacks to know when you're moving from one state into another. So if you can, favor the higher level API. Oftentimes we'll be able to modify the flow that we have between actors by using the ask pattern. And if you can, then you should do that. It's usually a better alternative. Okay, and that is all the content we have for now. We could talk about more complex scenarios, but I think we want to give time for questions. So let's see. I'm going to open here my chat, and okay, I don't see any questions on the public chat. If anyone has any that they'd like to share now, this is a good moment. And Tony, I don't know if you got anything directly to you. If so, this is a good time.
Hi, Alex, and thank you. Yes, I received 3 questions. I'll start with the first one, and maybe you can answer it for the team. If a circuit breaker is stuck between open and half open, can we increase the reset timeout? Okay,
excellent question. So let me go back to that diagram, because we had it's good to visualize this here. So I think the question is, if we're balancing between these two, can we start increasing the time? So typically what we call a back off. And the answer is yes. And we didn't show it here, but the constructor of the circuit breaker, here we go, actually we have like 3 different constructors. And one of them allows us to provide a multiplier here for the back off. So let's see if I remember what this is. If we go into the constructor in here, if we use the default constructor in here of the circuit breaker, we have the same 4 elements we talked about, and we also have an exponential backoff factor in here. So we can set this to any number larger than 1, like we see in the require in here. And what that will do is every time we go back to the open state from the half open, the cooldown period is going to be multiplied by this factor in here. So if we set it to 2, would be a fairly common factor in here. Every time we go back, the time we're going to spend in that state is going to be twice the one previously. So I hope that that answers the question.
Okay, I've just received some more questions. The second question from the first round: do circuit breakers remove the need for timeouts altogether?
No, most definitely not. So we still have to think about what sensible timeouts are, and in all the different layers, right? So this doesn't remove the fact that we have to think about those, but we have an easier mechanism to handle them at each individual layer interaction, right? So here we've used one circuit breaker to sort of protect the interaction between users and services from the very long timeout we have in here that usually we do not have any control over. Okay, so we still have to think about them. We still have to choose sensible values, but we have better control, especially control over a pattern of failures using circuit breakers.
Great. Which thread does a circuit breaker use?
Okay, let's see. So that depends on which part of the circuit breaker we're talking about. I would say the creation of a circuit breaker is a synchronous call. So creating it itself is happening on whatever thread the creation of this actor is, or this component. Circuit breaker could be created from something that is not an actor. But probably the most important part of the question is, what about this when we're actually using or calling this method in here? And the answer is that this is still running in the same thread as the actor. So we are within the single threaded illusion. So this method with circuit breaker is being resolved on the thread of where the actor is running right now. But the tricky part is that if we're combining this with futures, then that future may well be running, will probably be running on a different thread. Here we've simplified it and everything is in the same execution context. So we're using the dispatcher as the execution context for this actor. But it may well be an entirely different one. The creation of this future could be on an entirely different execution context. So you got to be careful about which parts of this you're talking about.
Okay.
Any other, Tony?
Yes, there is. Is there a circuit breaker dashboard like Hystrix dashboard? Hope I pronounced that correctly. Could be the accent.
So if I understand the question correctly, can we visualize all the circuit breakers in my system? So if I've added a few of them, can I know where they're at? As far as I know, the monitoring tool from Lightbin does not show this. I'm not 100% sure, but I'm pretty sure it doesn't. So you would have to somehow monitor that yourself. Now, like I said, we have the transition methods in here, so we can do whatever we want in here. So on this notify me, I could potentially be triggering an event in some separate system, right? If I wanted an event there that goes to some other dashboard. Here I'm just logging, so if I'm monitoring my logs, I could look for a specific entry in here. But as far as I know, we don't get any free or any out-of-the-box monitoring of circuit breakers.
Okay, yes, there's another question. Where can I find a good example using Akka persistence to replay messages while circuit breaker was open?
Can you read that again, Tony, please?
Where can I find a good example using Akka persistence to replay messages while circuit breaker was opened?
So when a circuit breaker is open, so I'm just trying to figure out where they're coming from, because when circuit breakers are open, this doesn't affect how Akka persistence works. So if a command came in and you've identified that this command triggers an event and you've persisted that event happened. Okay, you made a decision that that event was produced from the command. So after you've decided whether or not to persist that event, you will use the breaker in here. So those, I'm not quite sure what the relationship they're trying to draw in there. I think they're two different concerns. You will see if the failure you're sending back here to the user, for example, is going to be a command over there, and if that is a persistent actor, then you will have to think about on that side whether those commands would represent events, whether you want to persist those, whether you want those to be replayed at all or not. And I don't think there's one right answer. You have to think about your specific use case.
Okay, I got some feedback that that was a good answer. So look, team, and thank everybody for joining today. We have no further questions. I will point out on the right-hand side there are 3 handouts there if you're interested in downloading them. I want to thank Alex and I want to thank all the team for their questions. A quick reminder to register for October's webinar, Akka Type Sanity for Your Actors. Don't forget to visit www.yoppworks.com for details on our reactive platform training classes. I'd like to thank you all again for joining, and we look forward to seeing you at the Reactive Summit. Thank you all, and I hope to see you soon.
Thanks very much for attending, folks.